And combinations are going to be about talking about how many ways can something happen. And the reason that this is going to be related to probability when we get to it is because if you think about it, probability is the number of times that we get an outcome out of the number of possible outcomes. And so to do this calculation, sometimes we need to know how many different ways a certain outcome can happen in order for us to get the probability. And this idea is called a combination. So we are going to, the main example we're going to look at, our main example, is going to be how many ways can I select students out of a class. That's going to be the main example that we're going to use. So starting with the not very exciting example. Each of these, we're going to have a table. And this table is going to be very boring because we're going to have number of students selected, and then number of possible ways I can select them. All right? So let's start with the case where I have no students in the class. That's a very sad time. And so if I have nobody there, what are the different possibilities of the number of students I could select out of 0? 0. How many ways can I select nobody? 1. I could select no one, and that's what I could do, and then be very sad because I don't have any young minds to educate. There's only one way that can happen. All right. One student wants to be my student. Okay. So this table is going to look the same as it looked before. So we have number of students, and then the number of ways that I could select. Okay? So what are my possible amount of students that I could select out of 1? I could select 1 or 0. Okay? And you can think about selecting them for maybe I'm picking them out how many students I would want to receive extra credit or get to go on a field trip or get sent to APAD. So how many different ways can I select? So we just have Marley in the class. How many different ways could I select nobody? 1. 2.
I'm sorry.
How many? Okay. So I could not select her. And that's the only thing I can do. How many different ways could I select 1 student? 1. I could either pick her, that's the way that I select one student, or not pick her, which means I'm selecting 0 students. So what are the possible number of students I could select out of 2? I could select both of them. I could select one of them. I could select none of them. How many different ways? Let's start with 0. How many different ways could I select neither of them? 1. I could just say, sorry, you're not picked. How many different ways could I select one of them? 2. I could either pick Marley or I could pick Sam. That's 2 different ways that I could select one student. Okay. How many different ways could I select 2 students? And in this case, we're saying there's two different ways that we can answer this question. And that is a way in which order, we could decide whether order matters or not. So in other words, does picking Sam first and then Marley any different than picking Marley first and then Sam? In the case of combinations, our answer is no. If I've selected both of them, then I've selected both of them, and that's that. So the answer here is 1. There's a different type of these called permutations where the order does matter. So like if I'm picking numbers for you think about a combination lock, which should really be called a permutation lock, because the order that you enter the numbers in matters. I can't just say out of all the numbers from 1 to 60, I'm picking 15, 25, and 35. For me to break into your locker, you would also have to tell me what order those numbers go in. Picking 15, 25, 35 is a different combination than 25, 15, 35. So that's the idea of a permutation. But we're talking about where order doesn't matter. So there's only one way I could select both of them, and that's to select both of them. So now I'm just going to have the front row. Since I have 2 people in the front row, now I'm going to have the third person in the front row. Okay? You're in my class now. Congratulations. All right. So we think about how many different ways could I pick nobody? 1, where I pick none of them. How many different ways could I pick all 3 of you? 1, which is just to pick all 3 of you. How many different ways could I select 1? 3. I pick you, or I pick you. 3 different ways. How many different ways could I select 2 out of the 3 people? 1, 2, 3. Those are the different pairs that I could have, that I could pick out of the 3.
So the ending to the 0 and the final number, the max value, will always be 1.
That seems to be the pattern, yes. Guess what we're going to do next? You'll never guess. 4.
Oh my god. Oh, this kind of
So, hang on. So, I hear that somebody has already seen where this is going. And we will talk about, this is, you have seen this before in Honors Algebra 2. You actually talked about this before. And so we're going to talk about what that is and what it has to do with combinations. We're getting there. So, in earlier years, they had not seen that before. And so then I showed an Algebra 2 thing, and it blew their minds. Your minds are not going to be as blown in this case, but I will show you what it is and why it's related. But let me talk about a way that we can do this efficiently, because there is a whole branch of mathematics about counting. And no, I am not making that up. It is called combinatorics. And the idea is about counting efficiently, which is actually more complicated than you might think. Because, for example, I would say one is going to be there's 4 different ways. I could either pick you, or you. All right. Then for 2, I think the most efficient method to start counting is to say, we're going to start by looking at all the ways that I could pair Sam with somebody. So we have 1, we have 2, we have 3. So now I've covered all the cases with Sam in the group. Now I'm going to cover all the cases with Marley in the group. We have 1 and we have 2. But not Sam, because I've already covered all the cases with Sam. And now all the cases with Aiden. Only 1 that I haven't talked about yet. So 1, 2, 3, 4, 5, 6. And here's another idea that you might run into with combinatorics. Instead of listing out the cases with 3, and here's where the symmetry comes in, because selecting 3 is the same as having 1 person that is not selected. If I select 3, that's the same as picking 1 person to not select. So I can either not pick you, not pick you, not pick you, or not pick you. 4. Picking everybody, 1. Not picking 6, remember, is the same as picking 6 people out of the 7 is the same as not picking 1 out of the 7. Have fun with these. Remember, once you get 2, you're going to get 5, because picking 5 is the same as not picking 2. Once you get 3, that'll tell you 4. Here's some notation. This is called N choose K. And asking this is the same as asking, there are a few different questions that I can answer with this. So let's say that I flip a coin. So I can either have heads or tails. Then I could also say, let's say I flipped that coin 4 times. Well, my different outcomes is I could have no heads, 1 head, 2 heads, 3 heads, or 4 heads. And we could list, let's say that I want 2 heads and 2 tails. We could look at how many different ways that can happen. Well, it turns out that there are 6 different ways that can happen. Right? I could have 2 heads here. I could have heads, tails, heads, tails. I could have heads, tails, tails, heads. And what I'm doing is I'm using the exact same method that I did to talk about choosing 2 people out of the 4. Right? You can think of this first one as whether I pick Sam or not. So here's all the cases where I picked Sam and who I could pair them with. So these 2 questions are asking about the same idea. Tails, tails, heads, heads. And so there are 6 different ways that I could do this. And there are a lot of different questions. Let's say that another example of something is, let's say that I'm shooting, I shoot 7 free throws. What's the number of different ways that I can make 3 of them? It's another way to ask that question. So this is N choose K. You'll see it's, the calculator likes to use this notation for it. So a big C for combination with N and K. The book and the formulas we're going to use this notation. And another day, we'll talk about what the actual formula is for figuring out what n choose k is, because the numbers can get really big really fast. Already at 7, these numbers are pretty big. So, in other words, n is out of how many we're choosing, and then k is the actual amount that we're choosing. So this would be 7 choose 0, this would be 7 choose 1, this would be 7 choose 2, and so on. This is why I say that the field of mathematics where you're talking about counting efficiently matters. Let's again start with Sam. How many different people could I pair her with? 6. 1, 2, 3, 4, 5, 6. Now Sam's out. How many pairs? 5. 4. 3, 2, 1. Add those together. 21. Which means that 21 also goes here. The way I would count up 3, and I'll give you one more minute to get this done, just to give you a hint to start with, is now let's start all the situations where Sam and Eleanor are paired together. And now I have to choose a third. How many different choices do I have for a third person? 1, 2, 3, 4, 5. Okay. Now I choose these two. Well, I've already picked you. And so now how many more choices do I have left? 1, 2, 3, 4. 1, 2, 3, 2, 1. Okay? So, and there's all the ways. Those are all the groupings that have Sam in them. Now I'm going to go with all the groupings that have Eleanor in them, and I can't and don't have Sam in them. So now I start 1, 2, and I need a third person, and then keep going from there. I'll give you one more minute. But that shows you that method of counting everything up. But you should get 35. And selecting 4 is the same as not selecting 3. All right. Now, I'm going to ask you an algebra question. And I want you to start thinking about what this is going to have to do with the combination. How are these tables possibly connected to what I'm about to ask? Oh, sorry, that's boring. Let's make it more interesting. I want you to expand out x plus y to the 4th power. And it's going to be a lot of fun. If you remember the shortcut, I don't want you to use it. Do it out the long way. I will give you 5 minutes. You should be able to do it in 5 minutes. Here's what I would do. X plus y times x plus y. What is that? It's x squared. There's a middle term here. Xy times 2. Square the first, square the last, multiply together, and double. So I have an x plus y times x plus y there. And then I also have an x plus y times x plus y here. This is x squared plus 2xy plus y squared. And now I just have 2 terms multiplied together, and I can start to distribute them out. Have fun. X squared times x squared is x to the 4th, plus x squared times 2xy, that's going to be 2 There's 3 x's here and a y. X squared times y squared. And now we get to distribute this term. I've got a 2xy times x squared is 2x to the third y. And then I have 2xy times 2x. Oh, these two terms are going to end up being combined together, etc. If you want me to, like, if you did something wrong and want me to check through it, then talk to me later. But here's what you should notice. Here is 1, 4, 6, 4, 1. Which matches this. So why is that happening? What does this have to do with flipping a coin or selecting students? Well, if I start doing, I have x times x times x times x. So I'm selecting, I'm multiplying, I'm picking 4 of the x's to multiply together. The only term that does that is that 1x to the 4th term where I take x times x times x times x. For the x cubed y terms, those come from, well, I could have x times x times x times y. I could have x times x times y times x. I could have x times y times x times x, or I could have y times x times x times x. So how many different ways could I select one of the y's out of the 4? 4 of them. Then my x squared y terms is selecting 2 of the y's out of the 4, which is 6. So really, I am choosing how many y's to multiply together out of that group. And yes, this is from what is called Pascal's triangle. What's the pattern again? How did we get the next row in the... Add the 2 above it. So this is 1, then 1 and 4 is... 1 and 4 is 5. 4 and 6, 10. 10. 15. 10 and 10, 20. 15, 6, 1. And here is your 1, 7, 21, 35, 35, 21, 7, 1. And we'll get a formula for this later on.